So far we've learned that the momentum of an object changes as it interacts with other objects. Other objects will exert forces that cause changes in momentum. The total momentum of an isolated system, however, does not change. If you have a group of objects that are exerting forces on each other, but otherwise isolated from the outside world, then there are no external forces, no outer forces exerted on the system, and so there's no net force on the system, therefore the momentum of the system does not change. So if we add up the momenta of all of the pieces of the system, we would find that that total momentum does not change. One good example of this is if we have two objects. If we have two objects that are just exerting forces on each other, but are not experiencing forces from the outside world, then we can conserve momentum for that two-object system. And we can say that the addition of the momenta of the two objects initially is equal to the addition of the momentum of the objects finally. One classic experiment of conservation of momentum is something called Newton's cradle. So with Newton's cradle, you have some balls, some metal balls that are hanging by strings and are allowed to collide with each other. So as you can see, when one of those balls comes in, it brings some momentum with it. It strikes its neighbors, and in order to conserve momentum, a ball at the other end flies off with the same velocity as the incoming ball. We can see over here on the right, there's the Newton's cradle in which two balls are lifted and then allowed to collide with the other balls. And because the two balls worth of momentum flies in, then two balls fly off the other end with the same amount of momentum. So momentum is a very useful tool for analyzing collisions. If you have two objects that collide, immediately before and immediately after, the momentum is conserved because during the collision, the two objects are just exerting forces on each other, and typically other forces like friction don't have a lot of time to interact with the two objects and cause them to lose much momentum. So during a collision, which typically happens very quickly, we can conserve momentum, and we can say that the initial momentum of the two objects added together is equal to the final momentum of the two objects added together. Rewriting this in terms of masses and velocities, we can say that the mass of object 1 times its initial velocity plus the mass of object 2 times its initial velocity will be equal to the mass of object 1 times its final velocity plus the mass of object 2 times its final velocity. Now, when we use this expression to analyze collisions, we have to be very careful about the signs that we use for the velocities. Some velocities will be positive and some negative depending on the directions that the objects are moving. So for instance, if this is an initial snapshot of our two objects coming together to collide, then the initial velocity of object 1 would be a positive number, while the initial velocity of object 2 would be a negative number, assuming that to the right is in the positive x direction.